So molecules are the smallest unit of matter that there is. Can we see them with just looking at them with our eyes?
No.
No. We would need a really high-powered microscope to be able to look at them. All right, so you had just told me that they're really smacked together in what?
Solids.
In solids. All they do is what?
Vibrate.
All they do is vibrate. There are always molecules in liquid. How are those molecules inside that liquid? Are they really tight like that?
They're like tight, but a little bit.
Yeah, they're kind of like, this would be a solid, right? How could you show me molecules inside a liquid with your hands? Do they kind of move around, but they kind of stay together? See how they're kind of moving, but they're still together? Can they sometimes go like that and then come back together? Come apart a little bit and then come back together? All right, what about, pretend like these are our molecules. What about in gas? They're kind of all over, right? They're just floating wherever they want to go. What about a solid? Do they move? What do? They vibrate. What about liquid? Are they moving around? Are they completely apart like this though?
No.
No, they're still kind of together, aren't they? How about gas? They just go wherever they want to go. Show me a solid again. Do they move? What do they do? Vibrate. Liquid?
It's like you're washing your hands in
Gas? Okay. Can you kind of visualize that in your mind?
Yes.
Good. Because what we're going to do is we have some adults that are here to pretend like we are looking under a microscope really closely at solids, liquids, and gases. So when they come in, we're just going to observe them. Do you know what that means?
Yeah.
You observe something. What do?
You look.
You just look at it. Are we talking?
No.
Are we laughing?
No.
No.
Touchy?
We're being scientists, right?
Mm-hmm.
Okay. I'm going to see how many of you can figure out who's the solid, who's the liquid, and who's the gas. We're just observing though. Okay. Come on in, molecules. We have different types of matter.
Do you want to stop there?
Yes, because I have the video going. Thank you. Okay, so let me zoom out a little bit here. Okay, what if they start jumping around? Ooh, okay. Now, did you notice something about what we had just talked about? Did you make some observations? Who thinks they can identify a gas? Okay. Go stand by actually I'm going to have you tape that to the gas. Got it? Maybe, if I can hand it to you. Okay. Go put that on the gas. Right on them. Go stick it to her. Do you agree with Raylyn?
Yes.
Okay, why is she gas?
Because
What do you notice about her molecules?
they're
They're what?
moving.
Yeah, they move around, don't they? Like if she didn't have a hold of that, would those balloons just kind of, those molecules just go wherever they wanted to go?
Yeah.
All right. Who thinks they could identify the solid? Agree or disagree?
Agree.
Why do you agree with that being the solid?
Because it doesn't move.
When she was jumping around, did the molecules move?
No.
What did we learn? What are those molecules doing in a solid? They're vibrating, they're stuck together, right? So then that leaves what?
Liquid.
That leaves the liquid. And what did we learn about Come on, get your molecules in a group. What did we learn about molecules in liquids? Are they always completely stuck together?
No.
What can they do?
They can kind of move.
Yeah, they can kind of move around. Can they kind of stick together a little bit?
Yeah.
Can they kind of come apart a little bit?
Yeah.
But they stay together, always moving around, don't they? All right. Thanks for your help, ladies. You are great assistants. You can wear those rest
Oh, yeah.
today if you'd like to. You look really good. Okay. All right. So here's the next part. This is the fun part.
Yay.
You each get a coffee filter.
Yay. I want to drink coffee. Yay.
You want to drink coffee?
Yeah.
Why on earth would I give you coffee?
Because you want us to have energy.
That just sounds like
Because you want us
a
to have
really,
energy.
really poor decision.
Yeah.
Giving
This has a
you
lot of energy.
caffeinated coffee.
Mm.
Okay. The next thing you get is a piece of paper. How lucky are you?
Not lucky.
But you'll notice on this paper that it says states of matter. And then what else does it say on it? Do you imagine if you don't have it, what do you think the states of matter are? I will probably recycle those, yes. You can just throw them in the loft. Thank you so much.
You should have kept those on.
Those are really high.
Thank you so much.
You bet.
All right, so molecules in a solid. Can you picture what they look like in a solid? Show me with your hands. How do they move?
No.
Vibrate, right? Okay. So now, what about solids? Or sorry, not solids. We just did solids, Mrs. Lofink. What about molecules in a liquid? What do they do? Are there as many molecules in a liquid?
No.
Do you remember when we were looking under the microscope up here?
Mhm.
Our pretend microscope, right? Were there as many molecules in a liquid as there were a solid? No. How about gas? Are there as many molecules in gas? No. It's like solid, there's a lot more molecules. Liquids, there's a few more. And then gases, there's really not very many molecules because they're just floating wherever they want to go. So here's what we're going to do now. I'm going to give you some little Fruit Loop cereals, not to eat, they're for science. I'm going to pour them into your coffee filter. And then what you're going to do is you're going to use those loops, the Fruit Loops, to show me what a solid would look like using the Fruit Loops. and then you're gonna show, like, cause you're filling that area for the solid. Then you're gonna show what it would look like if it was a liquid.
And
The Fruit Loops are the molecules, okay?
not to eat.
Not to eat, we're being scientists right
So you're
now,
putting them in here.
okay? Then you're gonna show me, like, what those molecules would look like in that gas shape.
Miss Sophie, how will we move the ones in the,
How what?
how?
You're just gonna show, like, you know, like when we were looking under the microscope, when they were standing up here, and they were just kinda standing here and nothing was really moving, that's how you'll represent it on yours.
Except
Okay,
when they
you'll just lay them down on there. You're not gonna have to show them moving. You're just gonna show, like, what would it look like in your solid with your Fruit Loops? Are you just gonna put one Fruit Loop in your solid area? Think about what you need to do. Are you just gonna put like 2 or 3 in the liquid?
No.
No. So think about what you're gonna have to do to make it a solid. It's crammed, packed in there, right? Liquid, they're kinda close together, but they still have a little bit of room to move around. Gas, they have all kinds of space to move around, cause there's not very many of them, right? Okay, so I'm going to see if you are understanding the molecules in solids, liquids, and gases by how you represent those molecules on your papers. Okay, you ready to give it a try?
Yes.
All right.
It's like here at home.
This is a perfect bowl.
This could be our snack.
You're a scientist right now, Lucas.
I wanted to, but I know I'll get in trouble.
Whoa. Trust me, they smell terrible. I'm sure they taste just as bad.
No.
I'm glad I got my mask on. I can't eat them. If I try to, they'll just go straight into my mask.
Mine smell like cupcakes because I made all cupcakes because I made them.
Can we start doing
Okay, go ahead and start showing me what molecules would look like in a solid.
This is not a very steady bowl. And if we put milk in it, it's probably
That would be a mess.
Yes.
My mom has done like the book and my brother has.
Can we go on to liquids?
Yes, once you have each of those states of matter completed, then go on to the next one.
Miss Laughing, one of mine are stuck together. Just lightly with a pie.
Okay, find some that aren't then.
I ripped it and it didn't like keep it on.
Ooh, I like it, Natalia. Looking good, Jenny. Holy moly, Haley. Good start, Reese. You could probably keep working, Lucas. Good job, Amy. Way to go, Raylan. Okay. Now, let's talk about this. I'm gonna work from right to left. So I'm gonna start over here with gas. We know that molecules in gas go everywhere, wherever they want to. So should that be full?
No.
No. I'm thinking you should have 2, maybe 3, 4, so that they have a lot of space to move. Does that still have a lot of space to move?
Yes.
Still yet?
Mm-hmm.
Now? Lots of space? I think that I would leave mine that way. You could even do that. There's just not as many molecules because there's nothing to contain them, right? How about for liquid? Jam-packed?
No.
No. Tell me when you think it's good. Whoops. I got molecules on the loose. Probably about there?
Yeah.
Because then they can still touch when they're moving around. I could maybe add, those are stuck. They can still touch, but they still have room to do their moving around. How about for the solid?
Jam.
Jam-packed, as many as I can fit in there. Keeping it contained in that spot though, right? Because it's a solid. So, could I just dump a handful? Keep dumping a handful. Is it taking up this whole shape?
Mm-hmm.
Yeah, it should. So, are they all crammed together?
Yeah.
Like packed together, stuck together? Yes. So does that visual that you have there, is that similar to what we saw when each of our volunteers was showing solids, liquids, gases?
Mm-hmm.
Very similar, aren't they? All right, you can have your snacks now.
Yay.
I'm gonna put
Thank you.